All right. So I know we don't have class during week 4, or we have the exam instead. So I wanted to make a quick video that talks a little bit about scientific notation and how we go about doing it. So the concept of scientific notation is that we can take really small quantities or really large quantities and write them in this format. Some number A multiplied by 10 raised to some power. So when we have these big numbers, we can effectively just take out powers of 10 and write this as a much simpler fashion. Now, one of the rules for scientific notation is that A, or in this case, the absolute value of A, the number that's there, must be between 1 and 10 in order for the number to be written in scientific notation, which means something like 3.1 times 10 to the third would be written in scientific notation. It can satisfy those things, but the number 310 times 10 to the third would not be written in scientific notation because I can actually pull out 2 more factors of 10 from this number. So that's the concept that we're taking a look at with scientific notation. So let's take a look at how we might write some numbers in scientific notation and what we get with those. So when we talked about it earlier, we talked about big numbers and small numbers. So here's, let's take a look at 3,500,000. So let's take a look at a number like this. Here's the process that we're going to go through to figure out whether or not this number or how we write this number in scientific notation. So I take my number and I need to determine where the decimal place is at this point in time. The answer is it's right here. We don't write it when we're writing an integer like that, but it exists and it's there. Next, we need to figure out where the decimal needs to go when this number is written in scientific notation. And the answer to that is always find the leftmost non-zero digit. In this case, the leftmost non-zero digit is the 3. And then that decimal place needs to go just to the right of that number. So the decimal place is currently here, and it needs to go right here. Once I do this, this is going to give me that A value we talked about earlier, 3.5, the number that needs to be between 1 and 10. And then I need to figure out how many decimal places I am moving this decimal, how many units. So we go 1, 2, 3, 4, 5, 6. So I'm moving this 6 digits. This value right here is my N. This value is my A. And when we talked earlier, our scientific notation is written as A times 10 to the nth power. So I would get 3.5 times 10 to the 6th power. So that's how we go about taking the number and writing it in scientific notation. Now, there's one little catch to this, and it's the N value, right? So the N value can be positive or it can be negative. So if my original number is larger than 1, my N value will be positive. If my number is less than 1, N is going to be negative. Now, when we deal with negative numbers, don't worry about it, right? Negative numbers are just numbers that are negative. I take a look at the physical number, the magnitude. If it's greater than 1, my exponent is positive. If it's smaller than 1, my exponent is negative. So let's take a look at 2 instances where we might see this. So let's take a look at 3,600, and we're going to write this number in scientific notation. So first thing I can note is this number is greater than 1, so my exponent is going to be positive. I say, where does it belong right now? So where's the decimal point at right now? where does it need to go? Needs to go to the leftmost digit, just to the right of that. And I'm moving it over 3 decimal places. So my decimal's there. My A value is going to be this 3.6. I'm moving it 3 digits over, 3 factors of 10. And since my number was initially greater than 1, my exponent is positive. So 3,600 is equivalent to 3.6 times 10 to the 3rd power. Now let's take a look at an alternative. Maybe 0.00015. All right, so I need to figure out where does the decimal place need to go. It's nice because where it is, when we write these numbers that are smaller, we always write the decimal there so we know exactly where it starts. It needs to be at the leftmost digit and just to the right of that. So it needs to go right in between the 1 and the 5. 2, 3, 4. So I'm moving this 4 digits. That means my exponent is going to be a 4. My A is going to be formed by this right here, 1.5 times 10 to the 4th. But because this number was less than 1, my exponent is going to be negative. So this becomes 1.5 times 10 to the minus 4. And so that's how we differentiate between positive and negative exponents. The negative exponent is going to tell me that my original number is much smaller than 1 from the start. So when we have negative values in here, maybe I'm looking at negative 3. Negative 3,140,000. Let's take a look at this number right. All right, negative numbers are just numbers that are negative, so I ignore it and follow the same process, and then at the end, I just remember that I was dealing with a negative number. So my decimal's here. I need it to come over here to the leftmost digit. I am moving it 6 units over. So when I take a look at this number now, I can rewrite it. My A is everything right here, negative 3.14. I'm moving it 6 units. And since my number, not the negative sign, the number is larger than 1, my exponent is positive. So negative 3,140,000 can be rewritten as negative 3.14 times 10 to the 6th power. That's how we go about writing numbers in scientific notation. So if we have a number in scientific notation, we can backtrack and figure out what that number actually is. Until we get more comfortable with these things, it may be difficult for us to understand kind of what's going on with the scientific notation. And there's a little bit of a trick that goes along with it that we just have to make sure that we know. So let's take a look at 7.81 times 10 to the 4th power. We're going to take this number, which is written in scientific notation, and we're going to write it as a regular number going forward. So when I have my number written in scientific notation, here's the process I follow. I'm going to write out my A value, and then I'm going to take the decimal place, and I'm going to move it this many ways. So this is kind of just doing everything backward, right? We said we started here, and we moved it over here, and that gave us our decimal. Now we're taking where we moved it to, and basically moving it back to where it was, times 10 to the 4th. Now, remember, the positive exponent told me that the number was greater than 1 in magnitude. That can help us out when we're doing this. But if my exponent is positive right here, what I want to do is take my decimal place where it is and move it to the right. I'm going to move it to the right 4 units. And this is where the decimal is going to go now. But I have these gaps right here that I need to fill in. All we do is if we have a gap like that, we just write in a 0. So now I can say that 7.81 times 10 to the 4th is the same as 78,100. So that's how we go about working backwards when we deal with it. Positive exponent, move it to the right. If we have a negative exponent, we'll move it to the left. So let's take a look at 1.35 times 10 to the minus 7. 1.35 times 10 to the minus 7. When we're taking a look at this, here's what we're going to do. Same process. I'm going to take my A value, 1.35, and I'm going to move that decimal to where it should be. Since my exponent's negative, that means this number is going to be smaller than 1. I'm going to take it, and I'm going to move it 7 units to the left. All those little gaps, I fill in with 0. So this number is equivalent to 0.12345 zeros in front of the 135. 0.0000135. So that's how we go about doing problems like this, working forward and working backwards when it comes to those. So let's do a couple more examples of these just to make sure we understand exactly what we're doing, and we'll write them out in different ways. So let's take negative number here. Negative 7.201 times 10 to the 9th. All right. Negative numbers, just numbers that are negative. We don't worry about that. So when I go about trying to solve this right here, I'm going to take my number here, negative 7.201, and I'm going to move it to the right 9 positions right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's where that's going to go. Everywhere I see a little gap, I'm going to plug in a 0. So negative 7.201 times 10 to the 9th will be equivalent to negative, that should be 7,201,000,000. And then we'll do one more with the negative exponents. 3.0 times 10 to the negative 3rd. 3.0 times 10 to the negative 3rd. I take my A value, 3.0. 1, 2, 3. I'm going to move it over 3 units and write in my extra zeros here. So now this becomes 0.003. And we could tack on that extra 0 if we want to. There's things called significant digits that are important that you'll probably learn about when it comes to chemistry in the ways that we measure things, but it may not be necessary depending on how many significant digits we're trying to report things to. But both of those should be sufficient when it comes along those lines. All right, so now we know how to write numbers, big numbers in scientific notation. We know how to take scientific notation and write them as regular numbers. So let's take a look at times where we might do multiplication or division in scientific notation. So the first thing we need to know when we do that are some exponent rules that exist. So if I have some number A and I raise it to the nth power, and I'm multiplying it by some number A, the same number A, raised to the nth power, this is equivalent to A raised to the n plus m power. So what does that mean to us? That means if I have 10 to the 3rd times 10 to the 4th, this is equivalent to 10 raised to the 3 plus 4. which is the same as 10 to the 7th power. So that's the rule that we're going to have to exploit here when we're doing multiplication. And then we have division. A to the n divided by a to the m, same base right here, is a to the n minus m. So what that means is if I have 10 to the 7th over 10 to the 4th, I have 10 to the 7 minus 4, which is 10 to the 3rd power. So if we understand those things right there, we can combine numbers in scientific notation with multiplication and division. So let's do a couple of examples when it comes along with those types of problems, because there is going to be one little trick we have to pay attention to when it comes. So we're going to do a couple of simpler examples here. So let's take the number 2.1 times 10 to the 3rd, and we're going to multiply that by 3.0 times 10 to the 2nd power. So we're going to multiply these two numbers together. So here's how we go about multiplying these two numbers together. First thing I'm going to do is I'm going to take those front values and I'm going to multiply those together. Then I'm going to take my exponents, or sorry, my factors of 10, I'm going to multiply those together. And then I'm going to see what my result is on the back end. So what we're going to do here is we're going to take 2.1, multiply it by 3. And when I do, I get 6.3, 10 to the 3rd times 10 to the 2nd. Remember, with multiplication, these add together. So that's going to become 5. So when I take 2.1 times 10 to the 3rd, multiplied by 3.0 times 10 to the 2nd, I get 6.3 times 10 to the 5th power. And that's the concept of multiplication when we deal with it. We take those numbers at front, we multiply them together, and then deal with the exponents. So let's do 1.78 times 10 to the 5th, and let's multiply that by 3.21 times 10 to the 11th power. First thing I do, I'm going to take these numbers out front. 1.78 multiplied by 3.21. I'm going to multiply those together. And I'm going to multiply that by my tens here. 10 to the 5th times 10 to the 11th. And then I'm going to see what I get when I do the math on the back end. So let's take a look at those first two. 1.78 times 3.21. This gives me 5.7138 times exponents. When I multiply them, they add together. 5 plus 11 is 16. So these numbers will be 5.7138 times 10 to the 16th power. So that's how we go about multiplying two numbers in scientific notation. Now, let me give you one little caveat to that rule, something we might have to think about if we see it happen. So let's take 5 times 10 to the 4th, and let's multiply that by 3.1 times 10 to the 7th. So now we're going to follow that same process. Take 5 times 3.1, put that out front. Take my tens, put them over here, and then see what happens. When I multiply these numbers here, 5 times 3.1 is 15.5. My exponents here add together. So it's 4 plus 7 is 11 times 10 to the 11th. Now, this number is not written in scientific notation. In order for it to be written in scientific notation, this number must be less than 10 and greater than 1. It is 15. That is larger than 10. So what happens here is I have to adjust my answer just a little bit. So when I take a look at this, okay, what do I have going on? If this number is larger than 10, I need to move this decimal place over here. And then I need to add 1 to my exponent over here. So I get, instead of 15.5 times 10 to the 11th, I'm going to get 1.55 times 10 to the 12th. Another way we could think about it, which may be a little bit more complicated, is 15.5. If we write this in scientific notation, is 1.55 times 10 to the 1st. And then I would effectively be multiplying that by 10 to the 11th. These exponents add, there's nothing to do with that, and that's where we get that extra 1 where it shows up right there. So if I have a case where I'm multiplying 2 of them together, and this number right here is larger than 10, what ends up happening is I need to move that decimal place to the left, and I need to increase that exponent by 1. So let's do one more case with that where we're taking a look. 7 times 10 to the 3rd multiplied by 3 times 10 to the 4th. Simple example here. Multiply my numbers out front. 7 times 3. Multiply my powers of 10. And then I get 21 times 10 to the 7th power. This number is larger than 10. So I'm going to move that decimal to the left 1. And I'm going to add 1 to my exponent here. So this becomes 2.1 times 10 to the 8th power. That's how we deal with that. All right. Next one we'll talk about is division. Division with exponents. It follows that same rule, except we use the division rule for exponents, but just about everything else follows the same suit. So let's do 9 times 10 to the 7th divided by 3 times 10 to the 2nd power. So we're going to deal with this right here. So what I do is I take the numbers out front and I divide them. 9 divided by 3, and then I multiply it by 10 to the 7th over 10 to the 2nd. 9 divided by 3 becomes 3. 10 to the 7th over 10 to the 2nd. These subtract. 7 minus 2, that becomes 5. So I get 3 times 10 to the 5th. Take these A values out front, divide them. Take these right here, divide them, 10 to the 7th over 10 to the 2nd. And then I just rewrite this in scientific notation on that. So that's how we go about it. Sometimes we might deal with this, and we might get 8 times 10 to the 3rd, and we want to divide it by 4 times 10 to the 12th. We still follow the same process. 8 divided by 4, that goes out front. And then I'm going to take my 10 to the 3rd, and I'm going to divide it by 10 to the 12th. And I'll have those multiplications right there. 8 divided by 4 is 2. 10 to the 3rd over 10 to the 12th. That's 3 minus 12, which is negative 9. So the exponent I'm going to see on that 10 will be negative 9. 2 times 10 to the negative 9 power. So that's how we go about dealing with that. Don't be concerned if that shows up. Those are the rules that happen right there. And sometimes we have negative exponents in there, positive exponents. We just need to know how to deal with the addition and subtraction of positive and negative integers if they show up. All right, so just like with multiplication, there is a caveat to this where we might see something like 4 times 10 to the 3rd and I'm going to divide it by, let's do a little bit different. Let's not do 10 to the third. We'll do that one instead. So we might get 4 times 10 to the 8th divided by 8 times 10 to the third. Let's do this. All right, so I'm dividing these. I follow the same process. Divide the numbers out front. Divide those factors of 10, and then I'll write my number in scientific notation. 4 divided by 8, that's 1/2, which is 0.5, times 10 to the 8 minus 3, 5th power. Now, this number is smaller than 1, which means it is not written in scientific notation. So what I have to do is I have to move that decimal place just like I did with the multiplication, except I'm moving it in the other direction. So instead of being here, it needs to go here. And since I'm moving it this way, I'm losing a factor of 10 on the back end. So this number will become 5.0, maybe just 5, times 10 to the 4th power. So again, I'll show you that little thing, because we have 0.5. If I write this number in scientific notation, it becomes 5 times 10 to the -1 exponent. And then I get that multiplied by 10 to the minus 5, or 10 to the 5th. 5 minus 1 gives me 4. And that's how we actually do it on the map. But in general, if I'm doing division and my A value is less than 1, I need to move that decimal over to the right, maybe a couple of units, however many units I move it over, I subtract that many units from my exponent right there. All right. Let's do one more with a little bit different type of example where we have all that stuff. We're going to do 2.5 times 10 to the 4th, and we're going to divide it by 3.1 times 10 to the 9th power. All right, so first things first, do the division. 2.5 divided by 3.1, 10 to the 4th divided by 10 to the 9th. So this one I'm going to need a calculator for. 2.5 divided by 3.1 gives me 0.80. We'll just round it to 3 right there, 0.806. 10 to the 4th divided by 10 to the 9th, 4 minus 9 is -5. Now, just like over here, this number is not between 1 and 10. So I need to move that decimal to the right one. And then I'm going to subtract that exponent from 1. So the number on the left becomes 8.06. And then we need to be just a touch careful. -5 minus 1 is -6. So it becomes 1 unit smaller. 8.06 times 10 to the -6. So I think that about covers it, but I will show y'all one more thing because I think it shows up in your homework. And I don't want us to get too concerned with it. But there's some things that'll show up where it'll be, you might see 0.315 on top multiplied by maybe like 13,000, then you divide it by 0.0418, and then they might square it. And this is just going to start looking ugly and ugly and ugly, but we don't want to be concerned with it going forward. So if we see something like this, here's what I do. I always like to do these types of problems step by step, so I don't screw it up. Right? The order of operations, PEMDAS, I always say GEMDAS, I like that better. But basically says you do everything in the parentheses first, and then you do exponentiation, multiplication, division, addition, subtraction. So we take a look at the parentheses here. I'm going to take everything on the top and I'm going to multiply those together. 13,000 times 0.315. So this right here becomes up top 4095 divided by 0.0415, and everything's squared. All I have done from these two steps is multiply these two together right here. Then I'm going to continue to do what's in the parentheses. I'm going to divide those two numbers. So now I've divided these two numbers, and I got 98,674 point. We're just going to round this to 7 to keep things simple for now. Don't round until the end. That's the rule there. So I have that right there. And then the last step will be to square it. Now I'm going to square this, but I'm not rounding in my calculator, so don't worry. And so when I square this quantity, now I'm rounding this to 2 decimal places, I get this big honking number right here, which would be 9,736,696,182.32 on the back end. Now, you might want me to take this number and write it in scientific notation. Not a problem. We follow those steps that we did earlier. I'm going to take my decimal from where it is. I need to figure out how many units I'm going to move it. The answer is 9. I'm going to move it over 9 units. And then I can write this number in scientific notation. Since this value is larger than 1, my exponent's going to be positive. And then the problem will probably say something like, round it to 3 significant digits. All that means is that when I'm writing out my number, 9.736696, yada, 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 times 10 to the 9th, 3 significant digits just means round this so I only have 3 numbers here. So the 3 significant digits, I'm going to use this digit right here, and I'm going to end up rounding it up. So this becomes 9.74 times 10 to the 9th. So I wanted y'all to see that example. It exists in your homework, I think. And it can look a little scary, but don't worry too much about it. Step by step. And then this kind of little trick here at the end going forward. So I think that video is going to serve its purpose for us. Hopefully it's helpful. And we'll continue on learning everything else as we go on in the class. All right.